NetIonic equations or reactions are sometimes important when we need to consider what species are actually taking part in the reaction. Reminder, a dissociation reaction is a separation of ions when an ionic compound dissolves. So something like iron 2 chloride, when it dissolves into water, will create iron 2 ions and chloride ions. And we need to balance this to show how many of each species is present. So for every 1 iron chloride that dissolves, we get 1 iron 2 ion and 2 chloride ions. A net ionic equation will be a reaction that shows only the ions or species that change during the reaction. That change could be a change of state or a change of charge. Anything that does not change during the reaction is called a spectator species. So if something stays exactly the same from the left side of the reactants to the products on the right side, then it's a spectator species. If you need to write a net ionic equation or reaction, the first thing you need to do is write all of the reactants and products, and then dissociate any of the ionic compounds and ionize any of the acids. Second, you need to cancel any of the spectator ions. So we want to leave out any of those things that stay exactly the same, so same state, same charge on both sides of the equation. Last, rewrite the equation, leaving only the species that changed during the reaction. In this first example, we have a piece of zinc that's added to a solution of copper 2 sulfate. We're going to write the net ionic equation and identify the spectator ion or ions. So if we have zinc and a copper 2 sulfate solution, this would be like a single replacement reaction, or it is a single replacement reaction that you might have seen in Science 10. So solid zinc plus copper sulfate, and as a single replacement reaction, we would end up with solid copper and a zinc sulfate solution. So there are all the reactants and products, and when we balance this, we put a 1 coefficient in front of everything. We want to rewrite this dissociating our ionic compound, so that's the copper sulfate and the zinc sulfate. So the zinc solid stays exactly the same. We get 1 copper 2 plus ion and 1 sulfate ion on the reactant side. And on the product side, we have a solid copper, that stays the same, a zinc 2 ion, and a sulfate ion. So the 1 zinc led to 1 copper ion and 1 sulfate ion. And on the product side, we have 1 copper, 1 zinc ion, and 1 sulfate ion. Now we want to cancel out anything that's exactly the same on both sides. If you look at the ions, there is 1 sulfate ion on both sides. Same charge, same state, and the same number of them. So 1 sulfate ion doesn't do anything during this reaction. It's a spectator. It just sort of floats along and looks at everything that's happening. So our net ionic reaction now is everything else that's left. So we have 1 zinc solid plus 1 copper 2 ion, resulting in 1 solid copper and 1 zinc ion. And there's the net reaction. So the spectator is the one that we crossed off. So the spectator ion in this one is the sulfate ion. Let's do one more example. A solution of iron 3 chloride is mixed with a solution of sodium carbonate. Write the net ionic equation and identify the spectator ion or ions. So again, we want to write out our equation, all reactants and products. So iron 2 chloride, FeCl3, and that's going to be an aqueous state because that dissolves in water, mixed with sodium carbonate, Na2CO3, and again that's aqueous. That's going to produce a double replacement reaction. So sodium chloride, NaCl, which is table salt, is soluble, so aqueous. But the second species, the iron 3 carbonate, is solid. So Fe2CO3, 3, and that's a solid state. When you look in your solubility table, you'll see that that is insoluble. It doesn't dissolve in water. So now if we rewrite this, first we got to balance. We're going to need 2 iron chloride, 6 for the chlorine, 6 sodium, and so we want a 3 in front of the Na2CO3, and a 1 in front of the Fe2CO3 taken 3 times. Now we can split up any of our aqueous species, so all the things that dissolve. So on the left-hand side for the reactants, we now have 2 iron 3 ions and 6 chloride ions. 6 sodium ions and 3 carbonate ions. On the product side, we're going to have 6 sodium ions and 6 chloride ions. And now 1 iron 2 carbonate. This is a solid, so it doesn't split up. We leave it as Fe2CO3, 3 solid. So looking at the reactants and products, we want to find any of the ions or species that stay exactly the same, so same charge, same number, and that means that the 6 chloride ions that show up on both sides are spectators. Same thing for the 6 sodium ions. They are the same charge, same state, and we have the same number of them. So those are the things that are the spectator species or ions. So now our net reaction is what we're left with, and that is 2 iron ions and 3 carbonate ions. And that produces the 1 iron 3 carbonate that we have on the product side. So there is your net ionic reaction. The sodium and the chloride were spectators. They didn't do anything during this reaction. So spectators are sodium and chloride.